Welcome back, everybody. Let's finish up our discussion of power analyses. So far, we've done quite a bit with power analyses. By hand, we've learned how to compute both a priori power analyses and also post hoc power analyses. This time, let's give our brains a break and let's compute power analyses using GPower software. For one of your research reports, you're going to need to compute a post hoc power analysis using GPower. I have some sample data, and I'm going to show you how to do that right now. For my sample research project, I collected data from two separate groups, men and women, and I asked them, on average, how many text messages do you send per day? And you can see that descriptively, females sent more text messages on average than males, 111 per day compared to about 79. I used SPSS to compute an independent samples t-test to see if there are statistically significant differences between those two groups, and although it was relatively close, it was not statistically significant. It's possible that this test suffers from insufficient power, and a post hoc power analysis would tell us how much power we actually achieved in this analysis. Although there are relatively large differences between the group means, there's also quite a bit of variability between the two groups, and the sample sizes were relatively small. I'm predicting that this was a relatively underpowered research study, particularly because those sample sizes were so small. This is what GPower looks like, and this is an example of some of the output that it gives. I'm going to show you how you can download GPower, and then I'm going to show you how to run a post hoc power analysis. One of the easiest ways to find and download GPower is just to Google GPower download. It's likely that this site right here will come up as your first search result. That link will take you here. From here, you can read about GPower and you can download it for free. You can also download help files to help you better learn how to use it. There are downloads available both for Windows and for the Mac. All you need to do is scroll down a little bit and find the specific file that you need to download. After you run the installation program and open up GPower, you're going to see this screen. You might want to take a few minutes to click on the menus and see which options are available. For example, GPower can do 5 different types of power analyses. From class, you'll recognize the a priori power analysis and the post hoc power analysis. I'm going to click on post hoc power analysis. Compute achieved power given the alpha level, which I have. For the test that I did, the independent samples t-test, I used an alpha of 0.05 two-tailed. Based on the sample size, I know my sample size. I had 15 people in each group. And based on the effect size, we can compute the effect size ourselves based on the basic descriptive statistics we have, but you're going to see GPower will compute effect size for us automatically. So I'm going to click on that option. You might recall from prior videos that the formulas we use for a power analysis differ based on the type of statistical test you use. I collected data from men and women, so I was comparing two completely independent groups. That means it was appropriate for me to do an independent samples t-test. So up here where it says test family, I'm going to leave that set at t-tests, but I need to pick the specific statistical test. So I'm going to come down here. I am comparing means, and I'm looking for differences between two independent means, two groups. This is the option that I need. Now I'll start filling in the specific information. We were doing a two-tailed test in that analysis. Now I need to enter in the effect size based on Cohen's d. I can compute that effect size myself, or I can click on where it says determine, and then I'll enter in the means and the standard deviations, and GPower will compute the effect size automatically. Let's try that. If your sample sizes are not equal, use this option, but my sample sizes were equal. I had 15 people in each group. The mean for the first group was the mean for the men, and they sent on average 78.67 text messages per day. The mean for the second group is the mean for the women, and they sent on average 111 text messages per day. The standard deviation for the men was 40.86, and the standard deviation for the women was 52.99. So there was roughly equal variance between the two groups, but a little bit more variability for the women. Now we'll click on Calculate and GPower will compute the effect size for us. In this case, Cohen's d equals 0.68. So there's a difference between these two groups of about 0.68 standard deviations, close to about 70% of one standard deviation difference. If you click right here, GPower will transfer that Cohen's d value back into the main window. Now we can close this calculator. When I computed the independent samples t-test, I used an alpha level of 0.05. And the sample size for the men was 15. The sample size for the women was 15 as well. That's all we need to do. GPower now knows our sample size, the effect size, and the alpha level that we used for our test. So it has everything that it needs to compute power. You can see that GPower is going to compute delta, which is also known as the non-centrality parameter. It'll compute a critical value for t, the same critical value that would be used for that independent samples t-test. It'll compute degrees of freedom for that t-test. And here's what we really want. It'll compute power. And remember, power is simply the probability of not making a type 2 error. That's why oftentimes it's listed as 1 minus beta. Alpha is the symbol that we use for the probability of making a type 1 error, but beta is the symbol that we use for the probability of making a type 2 error. So let's click on Calculate and find out how much power I actually achieved for this study that I already ran. Many people believe that 0.80 is a minimum sufficient level of power. That would give you an 80% chance of finding statistically significant differences when those differences actually exist. Let's see how much power I achieved in that study. According to GPower, my power level was about 0.44, so I only had a 44% chance of finding differences when those differences actually exist. And that's no good. That's definitely characteristic of an underpowered research study. This power level is consistent with the graphic that GPower displays. This red line shows the sampling distribution based on the null hypothesis being true. This blue line shows the sampling distribution based on the null hypothesis being false and the effect size that we found. For the independent samples t-test, the critical value would be right here at 2.04. That means we would only find statistically significant results when the difference between our means is located within this area right here. So all of this area right here represents power. If we were to compute the area in the distribution right here, we would see it's about 44% of that distribution. So in other words, about 56% of the time, when indeed there are differences between the two groups, we won't find them and we'll make a type 2 error. Don't forget to check out this tab right here. This tab shows all the information that went into our power analysis and also the results of the power analysis. I haven't found an easy way how to copy this information if you needed to paste it somewhere else, like in a research report. So here's what I would do. I click inside this window. I hit Control A to select everything. Then on my keyboard, I hit Control C, and at that point, you can paste that information into a Word file or any other type of document. Overall, GPower is a great program for computing power analyses. It's very flexible and it's free. Well, I think that's about enough for now. I hope you enjoyed learning about power analysis. Power analysis is one of those tools every researcher should know how to use. I'll see you in the next video. In the meantime, be safe.